So our goal is to get to a point with our experimental design where we can take the little design, the diagram that we did the first one on Friday, and then we're going to be able to turn it into a paragraph. Okay, so that's ultimately the goal, is to write that out in paragraph form. So we had already done this baby food problem yesterday, and so what I want to do is actually use your blank piece of paper, and we're going to practice turning the diagram that we did on Friday into a paragraph. All right? So turn your blank piece of paper that you just picked up, landscape, so sideways like this. Okay? And so what we're going to do first is we're going to recreate the diagram that we had drawn on Friday. So we're going to start with our 30 babies or whatever. Okay, remember we did that. We started.
We leave room to write ahead.
Yes. So what you need room for on your blank sheet of white paper is you're going to put this up at the top. You're going to put your little diagram at the top, and then we're going to label underneath it parts of the paragraph, and then we're going to write the paragraph. So use about a third of your paper. So up at the top, about a third of your paper is going to be your diagram. Okay? On Friday, we had taken the 30 babies, and then we split them into two groups. Remember, we had 15 babies, so you're rewriting this on your piece of white paper. We had our 15 babies, okay, and so then we had taken our 15 babies, and we had them do two different treatments. What were the two different treatments that we had done?
New food and
competitors. Good. We had the new food and then the competitors. Okay, very good. Now, the key is that we had to do this thing. We had to do what was called random assignment. Okay? Now, do you remember, based on our songs, what the purpose of random assignment, what does that do? Two things. Randomize does two things for us. What's one of them? Reduces bias. That's one. What else? When you need to spread unknown traits evenly, randomize. Okay, gotcha. So when you need to spread those unknown traits evenly, because it makes the groups the same, so the treatment is the Y. So that's what it is doing for us. The other thing it's doing. Okay, so we take our 15 babies. Then we're going to, after we do that, we're going to measure each. So we measure each baby's weight gain. Okay, weight gain. All right, and then we repeated it down here in the competitors food group. And then what's at the very end? We come together, and what do we do with those things right there? Then we compare the average or a proportion. So if you have amounts that are number values like weight, what would we do? Would we get an average of all those weights, or would we make a proportion out of all those weights? We will make an average, okay? Because numbers values average together. Compare the average weight gain of the two treatments. All right, so you have that written at the top of your paper. So now what we're going to do is we're going to take this, and I have a mnemonic device that I've created a song out of that's going to help us take it from a diagram like this into a paragraph form. So I'm going to go ahead and play that right now so that we can label those things. So it's going to be Strap Me Capped. Okay, so let me play the song, and then we'll go through the things. Now, if you look in your packet back a few pages, you have the songs, and the last song that you have actually shows you all of the words to this song. So we're going to start with the subjects that we have. We're going to randomly assign them with a big bag, and then we're going to shake the bag up. And then we're going to pull out half for each group or whatever. Treatments, state your treatments very well. Then we're going to measure each subject's response. That's when we measured each baby's weight gain. And then we compare their average or their proportion. All right, so let me go ahead and play that song for you, and then we'll put it on our paper that we've got. We're going to apply each one of these letters to our picture diagram, and then we're going to write out the paragraph. So here we go. So what part of the song was this right here where 30 babies is? Start with the subjects that you have. Okay, so that was that part right there. Start with this. Yep, and then, very good. Then we randomly assign them. This is kind of like the second third of your paper. This is the second third of your paper. Randomly assign them with a big bag. Now, the asterisk is also this random assignment, but that's the part where we say, you say randomly assign them by putting in a big bag. This is what the asterisk is. It's not a bad word. It's a whole process. Putting them in the bag, shaking well, and pulling out half of the babies for each treatment. Okay, so that's what that asterisk is. It's kind of a lot of things. That's why it's special there. It's the chorus, and it's shake them up, shake well, put them in the bag, shake well, pull out half for each treatment. Okay. Now, how about this part with the new food and the competitor's food? What part of the song is that? Very good. Treatments. State your treatments. Very well. Okay. And then what's this part here? That's the ME. Measure each subject's response to them. So that you would say, measure each baby's weight gain. Measure each baby's weight gain. And then the strap me cat, strap me cat. Okay, and then the last part is compare the average or the proportion. So the C is for compare, and then it's A/P. The reason it's A/P is because you have to decide if it was an what? Average or a proportion. Very good. Compare the average or the proportion. Okay, so now let's go and put our last part of this, and that's going to be our paragraph. Okay, so now the third half of your page, we're going to actually now write this whole paragraph out. So let me find some space for that. We'll try that over here. Okay, so now we're just going to say this all in words. So what we're going to do, we're going to say, start with 30 healthy babies. Okay, oops. Start with 30 healthy babies. Okay, start with there's 30 healthy babies. Okay, and then what's next? Randomly assign them. Okay, good. So good. That was our first part. Then we say randomly assign the babies by, and here comes the asterisk. Okay, I'm going to put the asterisk sign here just so you know where we are in the song. Putting them in a bag, because you have to describe how you randomize. Putting them in a bag. Shake well, because shake well is notating that you are randomizing. Okay? And pull out half of the babies for each treatment. So that asterisk is quite a bit of stuff you have to say. Okay, so there we go. We start with our subjects that we have, randomly assign them, and then the asterisk is putting them in a big bag, shake well, and pull out half the babies for each treatment. Okay? All right, very good. So now, where are we in our song?
Shake it up.
Nope. Treatments. State your treatments very well. So the treatments are treatments are, so that's the T of our song. The treatments are, let's see, what were they? The new food and the competitor's food. So treatments, state your treatments very well. Okay. Now, what do? What's M-E in the song? Measure what? E stands for each. Measure each what? Measure each baby's. Measure each subject's response to them. That means measure each baby's weight gain. Okay, so measure each baby's weight gain. Strap me cat, da 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 da. Strap me cat, shake your bag up, shake your bag up. Strap me cat, da 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 da. Strap me cat, shake your bag up, shake your bag up. Okay, now we're to the C, A/P. What's the C, A/P?
Average or compare.
Yep, good. Compare your average or your proportion. So we're going to compare the average weight gain, of the new food to that of the what? Competitors. Very good. We're comparing the average weight gain of the new food to that of the competitor's food. Now, that is a complete written out experiment. Very good. Because ultimately, in medical journals or in actual studies that go on in the world, that's what you see. That's what they have in after the first page of the written out journal that they give you. They'll tell you like this is about whatever, and then they'll describe it in a paragraph exactly how they did their stuff. Okay, very good. So let's go on to page 7 and let's do this problem here. Here we go. Number 2, a research doctor has discovered a new ointment made with natural ingredients that she believes will be effective in the treatment of shingles. And shingles is a painful skin rash. She thinks it'll be more effective than the current ointment on the market. 18 patients have volunteered to participate in the initial trials of this treatment. Of this ointment. Okay, so first question is a placebo necessary? Explain.
No, or actually, yes, because it doesn't have to do with pain.
Oh, okay, this is good thinking here. Okay, you ready? Listen up. A placebo is a good thing because it blinds the patient so they don't know which ointment they're using. Okay, so the good thing about a placebo is that it blinds the patient. The bad thing is that you're being mean to the patient if you're giving them nothing. I mean, like just a lotion that has no medicine value. Plus, look at what we were comparing. We were comparing the new ointment to the current ointment on the market. Okay? So in this case, a placebo means like no ointment at all. So we don't want to do that because that's just mean, okay, to the patients to have them not have any medicinal help at all. So in this case, we're going to say no. And here's why. So no, because we compare new to current, not new to nothing. Okay? Now, that means it is considered a control group. The current will be the control. Control can be the one currently on the market. So your current ointment will be the control group. Now, look at part B though. See, we like We like blinding it. That's what you guys said. We want to blind it because what we're measuring is pain. And if we're measuring pain, what kind of response is that? Psychological. And if we have a psychological response, then we should probably hide from them if they're getting the good one or the not so good one, whichever one that is. So can this be a single blind or double blind? What does single blind mean? Only the patient doesn't know. The patient doesn't know which ointment they're getting. What does double blind mean? That the patient doesn't know, and the doctor who's asking them how they feel and looking at the rash doesn't know either. So, what do you think should happen in this case? Should we blind this so that the patient doesn't know? Yes is the correct answer, and again, why is that? Because pain is the psychological response. Okay, now, how about the doctor? Should we make it so that the doctor does not know which ointment the patient doesn't get either? Why yes? I like yes is the right answer. Why yes?
Because why would she not want her medicine to be better than the other one?
Right. So, see, maybe she has an in with the pharmaceutical company or something. She could also give subconscious clues to the patient like, hey, look here, how you feeling today? This one, if I know you have the new one, then maybe I am assuming that you're going to be feeling better than the other people. See? So it would really be best if the patient or the doctor doesn't know. How could that be accomplished? How could we make it so that neither one of them know?
Make a third party choose.
Okay, so that there's a third lab technician. They know. But how can we make it so that the patient nor the doctor know which one they are getting? It's double blind, but physically, how can that happen?
Label the lotions A or B.
Good. Make the lotions basically look the same, or even not even do it. Label them A or B, make them look the same kind of package, all that kind of stuff. Okay, very good. So the answer here, we want to answer the question, which the answer to this question is yes. This experiment can be both single blind and double blind. And now we got to explain. And so if both ointments look the same, then we can hide from both the patient and the doctor which ointment the patient is receiving. Receives. Oops, I think I did that. I before E except after C, so I did that wrong, right? Is it supposed to be E-I-V-E-S? Okay. Okay, very good. All right, next. Describe how you will conduct this experiment. Include an explanation of your randomization procedure, your randomization method. So guess what, people? You know what this is? Strap me capped. Strap me capped right here. Part C. You don't have a whole lot of room there. So, question then, we're going to do a diagram and the paragraph. Can you fit all that in there? I don't know. If you can't fit all of that in there, the diagram and the paragraph, then you maybe could, on the piece of white paper I gave you, go and put it on the back of that. And so you could label on the other piece of white paper I gave you, you could turn it over and put number 2C, and then you could do that there. So let's go ahead. I'm going to help you with the drawing, and then I'm going to see if you can strap me cat from the drawing, okay? All right, so here's the drawing. How do we start that? We got 18 patients with shingles. 18 shingles patients. Good. Okay, now what happens? There's our S.
Randomized.
Good. So we start with the 18 shingles patients, and then we're going to randomly assign them with a big bag. So you're going to then write your little asterisks in this section 2, put them in a big bag, shake well, pull them out, and put half of them in. What's next? What are our 2 different treatments? State your treatments very well.
Placebo ointment?
Okay, so we have new ointment. Remember, we decided that we don't need a placebo one.
Is there 9?
We can put 9 in the new ointment one and 9 in the, what was the control group? The current ointment. Very good. In the current ointment. Okay, all right, very good. That's our treatments. State your treatments very well. And now what's ME? Measure each subject's response to them. Okay, so we're going to measure each patient's. What is this going to be that what do we measure? It's actually, we're going to do pain improvement, because don't we want to see how much it has gotten better? Very good. So I'm going to write this. Measure each patient's pain improvement. And do you think that would be on a scale of like 1 to 10 or something? Do you think that's going to be a number value, or maybe are we just going to say you improved, yes or no? I don't think saying you improved, yes or no is going to be helpful, because hopefully everybody's improving. Don't you think we need to like measure how much they're improving on a scale? Okay, so if we measure how much they're improving, that's a numerical value. What do you do with a numerical value? Do you do an average from it or a proportion from it? Okay, good. So we're going to compare the average or your proportion. And in this case, it's going to be the average. So we would write over here, compare the average improvement of the 2 treatments. Average improvement of the new and current ointment. Okay, so now I want you to take a few moments and write yourself a Strap Me Cat paragraph from this drawing. Okay, because that's ultimately what you need to be able to do, is write out a Strap Me Cat paragraph. Go. Okay, so to what population? Who can we actually infer our results to? So this is about that if you randomly select, then your sample's like the population, and you can generalize. Otherwise, if they are volunteers, listen up. If they are volunteers, then the volunteers might be more desperate, more have much worse condition than the typical shingles sufferers or whatever. So, who can we generalize our results to? These 18 volunteers only. And that sounds strange that we can only technically generalize to these 18 volunteers, but that's what happens, is experiments start small. And we see how the results are with this to see if it's worth then doing it on a bigger scale. So the only people we can infer these results to are the 18 or these volunteers. Okay? All right, what if you had taken a random sample from all shingles sufferers? If you had randomly selected from all shingles sufferers, then who could you generalize to? Then you could generalize to all shingles sufferers. So then you can generalize to all shingles sufferers. Sufferers. Okay, very good. All right, so now we're just going to practice that a few more times. So let's take a look at number 3. So pretty much from now on, this is practice, practice, practice. So here we go. Number 3. We wish to determine whether or not a new type of fertilizer is more effective than the type currently in use. So researchers have subdivided a 20-acre farm into 21-acre plots. Wheat will be planted on the farm, and at the end of the growing season, the number of bushels harvested will be measured. All right, so let's first get straight. What is our explanatory variable? The what? Excellent. Type of fertilizer. Our explanatory variable is that thing which we think may be the cause. Okay, so part A. What's the explanatory variable? The type of fertilizer. Excellent. So, explanatory variable explains fertilizer. Okay. What are we measuring? What is the response that we're measuring? Has to be an amount.
Number of bushels harvested.
Number of bushels harvested, yes. The response is something we can measure, so we need to put it in terms of what we are measuring. The number of bushels harvested. Excellent. And that's per acre. Okay, very good. Per acre. Okay, guess what? Draw an experimental design and make sure you include how you would assign the plots and so on and so forth. So, guess what you get to do right here? You get to do your little design, and then you're going to do the paragraph. So I'm going to stop right there and let you do it. Go. Okay, at this point, if you want to check what you got before you write your paragraph, start with your 20 acres. Randomly assign them by putting their numbers in a bag, shake well, pull out 10 acres for the new fertilizer and 10 acres for the old fertilizer. Measure each acre's number of bushels and compare the average number of bushels of wheat for the new and the current fertilizer. Okay? So write that in your Strap Me cap. Stuff. So let's talk about confounding or lurking variables. Do you think there's anything that we might have to worry about that we would get, like some acres all clumped together that would be really, really nice and fertile land so that it makes the wheat grow better anyways without even the fertilizer being in it? What could cause on the farm some of the land to be more fertile than others so that it's that's happening and not just the fertilizer? Rainfall, true. The what?
Animals good.
Animals living on it, good. How about trees? If you have an area with trees with a lot of shade, could that affect it?
Yes.
Okay, good. So let's write some of these things down. So we've got trees. We could have issues with the trees. If there was a section with that, we could get, what if there's a river in a certain section? Would we have lots of nice fertile soil in that area already? Okay, what else did you say? Animals eating it or pooping on it, giving it for more fertilizer. Good. So there's lots of different things that we might need to consider so that just random assignment is not excellent. All right, no homework for today, and we'll go on and practice a couple more problems tomorrow.